I will have to ask you, and we will have to be really firm about this, we cannot take photos of other school groups and students. Taking photos of ourselves with permission is fine, but it really is a big thing in this country, particularly that we don't take photos of other, especially younger children. So please be aware. I realise you might want to capture a great activity that younger children are doing, but unfortunately we cannot.
Can I just stress that we haven't talked about school visits yet?
Yeah.
But really, in this country, you do not take pictures of children anywhere. Okay. Well, you just don't do it. So please don't be tempted. Thanks.
Okay, today, let me talk about the day so you know what's going to happen. It's really important you know what's going to happen. We're going to talk, it's about space science, and all you are science teachers. Some of you may, you may have PhDs in astronomy or something like that. Some of you may not be so qualified. But we're going to look at different things to do with space. What I want to emphasise is how I would teach some of these topics to our students. So we're not doing things especially for you, I'm just demonstrating things that I do for my students. So I want to show you things that are dead simple, things that you could just put together in your schools back home, but also link with things perhaps which are perhaps a bit more technical. How can we start using new technology? So a real mixture of things. And you're going to have a go. The things that I get my students to do, you're going to have a go at, because I believe teaching you actually have to do it. So we're going to have a look at the solar system. We're going to build a dead simple telescope. We're going to have a quick visit to something called the Challenger Centre. So that's where we'll leave this building and go and see our Challenger Centre. because I want to show you that. We're going to build rockets, and this afternoon we're going to launch the rockets. We've got lunch here. Lunch is provided, it'll be next door, 12 o'clock, so that the colleagues will set that up. And you've got about an hour to have lunch. You want to sit here, relax. If only during that time you want to go to the visitor centre. At 1 till 2, I've got these two rooms. Next door is an open space. And then this room here, and both these rooms will be locked off, so you won't be disturbed. So that you have that hour there where you won't be disturbed to use as you wish for prayers.
So we can pray here with you?
Yeah, I've split up two rooms. I understand sort of male and female. That room's got more room. Yeah. So if the bigger group, if there's more men want to go there, and then female here, that's set up. And we'll have water available for there. Okay. Hopefully that's long enough. Obviously, if prayer's gone on a bit longer, that's fine. I'm not going to come in. Nobody's going to disturb you and say, can you finish now? Use that time. This afternoon, we're going to go outside again, actually launch the rockets we've built, talk about comets. Then you have some free time to look around the gallery. So we would have been out and about. We'll have some free time. That's just completely free time. The only thing we have to be really careful of, be aware of time, is at 3:30, I'll show you where you have to meet. We've got a planetarium show. Now that is in English. You won't be able to video it, but hopefully you'll enjoy that. After the planetarium show, the centre will be closing. So we meet after the planetarium show, we agree where we're all going to meet so we've not lost anybody, and then it's goodbyes and hopefully that's a good day. Alright, so that's it, that's the day. Hopefully I've explained what you're going to get out from it. If you need any pens or anything to write anything down, I've got paper, please do ask, but like I say, you don't have to take notes. Okay. So who am I? My name's Andy. I've been a physics teacher in schools in England for about 23 years. I've now moved to work here, so this is full-time. So I teach, I still have students I teach, I still have A-level students. My students are actually in their class now. I've got a colleague covering the lesson because I'm with you, so I've sort of waved them by. I said, I'm not talking to you guys, I've got much more interesting people to talk to today. And I lead all the teaching and learning at what's called the National Space Academy. So, what are we trying to do? We're going to look at these activities. We're going to try to, and what I would love to happen, if I do an activity, one of you say, Andy, I do this in my school, but I do it like this. Wouldn't that be fantastic if you actually shared some things the way you do it? We're going to, like I say, discuss new technology. I'm going to try and compare and contrast those things through you. And I want you to take away an idea. Wouldn't it be fantastic? The last group I saw, who were actually English teachers from Egypt, a couple of them actually emailed me and they said they'd use one of these activities in their class, and that was just that's so worth it. So, here's a question I always set, and if you've done your PhD or you've done your degree in cosmology and you know the answer, where does space start? I always ask my students this: where officially is the starting point of space? How far do I have to go up before we're in space? Anybody? Does anybody know?
Starting of the space?
Yes.
They let it to us on Earth.
Yeah. How far? Go on. Give me a number in kilometres.
0.
1,000 kilometers.
1,000 kilometres we've got. What do you reckon?
Beginning of life. The beginning was the first man on earth.
I was thinking about how far you have to go up. So we've got 1,000 kilometres. 1,000 kilometres we've got. This is us going into space. So here's a video clip I made. That's us. That's the Space Centre. So we're launching into space. So that's where we are. That's the sort of parts of Leicestershire. Leicester you've driven through over the last couple of days. There's the highlights of Leicestershire and a region we call the East Midlands. It's only 100 kilometres away. And if we looked in space and we looked north, that's the north of the UK, that's the sort of view we would have. So 100 kilometres. I mean, like, I drive further than that to teach sometimes on 100 kilometres. It's only at 100 kilometres. It's called the Kármán line. It's the line at which aeronautical flight becomes impossible. So it doesn't matter how big a wings you've got, or the forces that to produce the lift. You'd have to be travelling so quickly you'd actually enter into orbit.
So this is started from the inside of the atmosphere.
It does, yes. There is still quite a lot of atmosphere at that height, yes. Where the International Space Station is, that's at about 400 kilometres. That's still got quite a lot of atmospheric drag on it. Every so often, it has to have a little boost to keep it in its orbit because it is still some drag on there. Don't know why. NASA actually defines at 80 kilometres. So there you go. NASA, the rest of the world thinks space starts at 100 kilometres. NASA says 80 kilometres. I don't know why, but they're different, I suppose. So that's the idea of space. What we tried to do to teach our students about scale, so this is our first activity. What I tried to do is to get students thinking about, well, okay, space is incredibly close. It's only 100 kilometres away. But how big are objects in the solar system? What about the distances? And here's a neat little activity. Here is the Earth. Who would like to be the Earth? Sorry, I need a volunteer to hold. Would you like to be the Earth? Hold the Earth. There we go. Okay. Here is the Moon. And I'm going to show you a picture. Here is pictures I've stolen from the internet. These are the pictures that are just available for anyone. Okay? And these are the pictures our students look at. So, here's a question. To my colleague there who's the Earth, who would like to be the Moon? Would you like to be the Moon? Okay. Looking at the pictures, and you've got to put yourself now, if you know the answer, you've got to put yourself now in the feet of my students, right? My students have seen those pictures. These are to scale. So that size and that size is about right. Okay? And I say to them, okay, you know that, okay, look at them. Where do you think, on scale, where do you think the Earth stays still, you've got to move, where did you think the moon will be? Stand where you think it's going to be.
لف يما.
Okay, that probably looks about... That looks about right, okay? I'm going to show you where on this scale it should actually be. You take the end of that string. And carefully, you take the end of that string. Carefully, do you want to walk that way? And you want to go as far as you can that way. This is how far they should actually be. You have to keep going, you have to keep going, you have to keep going. Hold it up, you have to keep going. That's it, you have to keep going. There. That's about it. That is how far the moon actually is away. And my students just cannot believe it. Are your arms okay? I'll be with you in a minute. I give my students numbers. Even with these numbers, I say how far it's away. And they just never get that it's that far away. Our moon is incredibly long way away for a moon. You could get every planet, think about every planet, Jupiter, Saturn, Uranus, Neptune, all of them. You could put them all side by side in this gap. Our moon is only just a moon. If it was any little bit much further away. But there is what I'm talking about. There is an activity to give our students our thinking, our model. I don't just give them data, and they're amazed. The picture should look like that. That's the picture we should show them in books. But we never do. Don't we? We don't see that picture, but that's what it should be. So, for yourselves, if you like this activity, it's dead simple. Whatever size ball you get, you don't have to have a blow-up globe. Get a football, get a basketball, whatever. Wrap string 10 times round, and that's how far it's away, roughly. Those figures are not bad. So dead easy to remember. Get a ball, wrap it 10 times round, that's how far the Earth would be away. Dead simple activity. Thank you. You're a wonderful Earth, a wonderful moon. Thank you. Thank you. So, excuse me. So, another activity. What about the other planets? We see these models. That's just a child's toy that sort of sits in a pram, and then that is a model. We've got one in the Space Centre. It's a model of the solar system. But again, it teaches people wrong. So what I've done for you, there's not quite one each, but sort of one between two. There's about 5 or 6 on each table of these. So, here is our solar system, right? This is the task. I've got some pens as well. That is a small section of the sun. So that's the sun. Here, I've marked where Neptune is. I've not put Pluto, obviously, because Pluto's not a planet anymore. So I've put Neptune. So, here's the task. Could you know, based on just pure guess, again, this is a typical teaching activity. I've just given it to my students as what I would call a starter exercise. So I have not taught them anything. It is literally complete guess. I give this to them and I say, on this line, don't draw them, just mark on that length line, perhaps with a